Hi there, welcome to brilliantmaths.com, where every student has an opportunity to excel in math. If you have not subscribed to brilliantmaths.com, please do so. You will find it so useful. The website is full of resources and materials that cover primary and secondary school mathematics. Today's lesson is taken from Brilliant Maths Module 1. If you don't have a copy, try and get a copy and let's work together. Today we are looking at standard form. We want to learn how to write numbers in standard form. What do we mean by standard form? A number is written in standard form if it is written in the form a times 10 to the power n, where 1 is less than or equal to a and a is less than 10. That means that a is greater than or equal to 1, but a is actually less than 10. So the numbers go from 1 to 9. Example 1. Write the following numbers in standard form. 63,000. For this number to be written in standard form, that means that we have to put a decimal point after 6. 6.3000 times 10 to the power what? What power of 10 do we need to multiply 6.3000 by to get 63,000? So let's see. 10 to the power 1, 2, 3, 4. If you multiply 6.3000 by 10 to the power 4, you'll get 63,000. These zeros are not significant, so it becomes 6.3 times 10 to the power 4 in standard form. The next example is 46,700. So we want to write 46,700 in standard form. It has to be in the form 4.6700 times 10 to the power what? What power of 10? Remember, we need to get 46,700. So we go 1, 2, 3, 4 again, times 10 to the power 4. The two zeros at the end are not significant, so we can write it as 4.67 times 10 to the power 4. The next example, we want to write 234.56 in standard form. But remember, for it to be in standard form, a has to be 1 or greater than 1, but less than 10. So it's more like moving the decimal point here. So it becomes 2.3456 times what power of 10? From the movement I did here, it's 10 to the power 2. If you multiply this number by 10 to the power 2, the answer will be 234.56. So the final answer is actually the same because the digits at the end are all significant. So our final answer is 2.3456 times 10 squared. In this example, the numbers are already written in standard form, but we want to write them out in full. So we have 6.489 times 10 to the power 6. So how do we get the full number? It means we are multiplying this by 10 to the power 6. So we could go 1, 2, 3, 4, 5, 6. What does that mean? The number is 6, 4, 8, 9. And then we have loops here without numbers. So we fill them up with zeros. 1, 2, 3. So the actual number, the original number, or the number written out in full is 6,489,000. Next we have 5.67 times 10 to the power 3. So we're multiplying this by 1,000. So if you multiply 5.67 by 1,000, you have 5670. If I do it the same way I did the first one, 1, 2, 3. I'm putting the loops to represent the power of 10. So power of 10 is 3. 1, 2, 3. So there's an empty loop there, and we'll replace that with a 0. For the next one, the number is 2.0789 times 10 to the power 2. So 10 to the power 2 is 100. We're just going 2 steps. So the number in full will be 207, 207.89. 207.89 was written in standard form to get 2.0789. The next one, 1.0824 times 10 is written in standard form. What's the full number? We're simply multiplying by 10, so it just goes 1 step. So the number in full is 10.824. For the last one, we have 7.8401 times 10 to the power 4. 10 to the power 4. It fits exactly. 4 digits, 4 loops. So that's equal to 78401. So the full number is 78,401. If you were to write this in standard form, you'll get that. Let's just look at it. Standard form, the decimal point comes here, and then you have 4 digits. And that's the same as multiplying it by 10 to the power 4. Try it out. It's very easy, and you'll find it interesting. Let's look at writing numbers in standard form, but with negative index, where the power of 10 is negative. Write 0.0032 in standard form. Remember that for a number to be in standard form, it has to be in the form 1 is less than or equal to a strictly less than 10. So keep that in mind. Our number is 0.0032. So a must be greater than or equal to 1. So we need to move the decimal point from here to after 3. And how many steps will that involve? So let's see. 1, 2, 3. So that will be equal to 3.2 times 10 to the power what? It will be 10 to the power minus 3. If you check with me, multiplying this by 10 to the power minus 3, the number, the decimal point will move 3 steps. 1, 2, 3, leaving us with 2 loops where we need to add 0. The place value of the digits will change, actually. The decimal point on its own really does not move, but the digits change place value when you multiply or divide by 10 or powers of 10. So the number 0.0032 written in standard form is 3.2 times 10 to the power minus 3. In the next example, we have 0.000729. We just need to determine how many steps, how many powers of 10 do we need to multiply by. So let's take the solution. All right, I'll write the number again. 0.000729. And this will be equal to, how many steps are we moving? Remember, the decimal point is coming here. So we'll go 1, 2, 3, 4. So that will be equal to 7.29 times 10 to the power minus 4. I hope you can see that, because it has moved 4 steps to the right. In this example, the numbers have been written in standard form, but we want to write them out in full. That's very easy. We have 1.23 times 10 to the power minus 1. That means that it's just one step. So the answer becomes 0.123. The second example is 7 times 10 raised to the power minus 3. So we're moving 3 steps to the left, moving the imaginary decimal point from the end of 7. So it becomes 0. How many steps are we moving? 3 steps. 1, 2, 3. So there are 2 empty loops there where we need to add zeros. So 0.007. And then the last one here, 7.8 times 10 raised to the power minus 6. So we're going to go 6 steps to the left. That means we are going to have 5 zeros before 7. 5 zeros before the decimal point. So it becomes 0.12345. So the 5 zeros, then 7, 8. So we have written out the numbers in full. We want to quickly order numbers in standard form. Write the following numbers in descending order. Descending order means start from the largest down to the smallest. They are all in standard form, so we need to order them. Let's take a look at this. Some of them have positive index and some have negative index. So that's the first thing you need to look out for. The first number here is 3.6 times 10 to the power 3, which is a positive index. 5.2 times 10 to the power minus 5, negative index. 1 times 10 to the power minus 2, negative index. 8.35 times 10 to the power minus 2, negative index. 1.743 times 10 to the power 4, positive index. And the last one is 6.08 times 10 to the power minus 8, negative index. So, descending order, we're starting with the largest. Look at all the numbers. The ones with positive index start with those because those are the bigger ones. This is 10 to the power 4, and this is 10 to the power 3. Let me write it closer. Don't forget that all of them are less than 10. All the numbers in the unit place are all less than 9. So, but this is to the power 4. That means that the number is actually going to have a zero loop here with an additional 0. So that number is going to be 17,430. So that's the bigger number. This number is going to be 1, 2, 3. It's going to be 3,600. So we can say that the higher the positive index, the greater the number. Take note of that. I'm choosing my words. The higher the positive index, the greater the number. So having said that, the biggest number here is 1.743 times 10 to the power 4. So we write that first, 1.743 times 10 to the power 4. So I'm going to take this out, and then I just circle this because I have done it already. The next, those are the only two with positive index. I'll take this out too. The next number is 3.6 times 10 to the power 3. I also circle it because I've written it. So we are left with the rest of them. 8.35 times 10 to the power minus 2 and 1 times 10 to the power minus 2. 8.35 times 10 to the power minus 2 is greater than 1 times 10 to the power minus 2. So that's the next number, 8.35 times 10 to the power minus 2. I circle it because I've written it. Then the next number is 1 times 10 to the power minus 2. I also circle it. What is left? 10 to the power minus 5 and 10 to the power minus 8. The number with 10 to the power minus 5 is greater than the number with 10 to the power minus 8. So we have 5.2 times 10 to the power minus 5. And finally, the smallest number in this set is 6.08 times 10 to the power minus 8. So I've ordered all the numbers. Always check to make sure that you're not leaving out any number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the numbers have been put in descending order, with the largest number being 1.743 times 10 to the power 4, and the smallest number being 6.08 times 10 raised to the power minus 8. Let's find out how we can do some calculations in standard form. Addition and subtraction. Example 1, or the first example, without using a calculator, evaluate giving your answer in standard form. So for the first example, we have 2.8 times 10 to the power 4 plus 1.6 times 10 to the power 4. Notice that both of them are in standard form, and they are being multiplied by 10 to the power 4. Both powers of 10 are the same. So you can simply add the numbers. So solution. So we have 2.8 times 10 to the power 4 plus 1.6 times 10 to the power 4, and that will give us 8 plus 6 is 14, carry 1. 2 plus 1 is 3 plus 1, that's 4. So the answer to that calculation is 4.4 times 10 to the power 4. Both of them are to the same power of 10. So that's very easy. Same with the second example, it's just that it's subtraction. Both have the same powers of 10. This time is minus 4. So you can simply subtract because the powers are equal. So in the same way, we have 2.5 times 10 to the power minus 4 minus 1.6 times 10 to the power minus 4. Simply subtract, and it remains times 10 to the power minus 4. 5 minus 6, borrow 1 from 2. 15 minus 6 is 9. So the answer is 0.9 times 10 to the power minus 4. However, when the powers of 10 are different, then you have to simplify the number, write it in full, carry out your operation, and then write it again in standard form. So we're going to look at that in this third example. So 2.5 times 10 to the power minus 4 is equal to, remember, 4 steps to the left. So that's going to be 0.00025. And then 1.6 times 10 to the power minus 5 will be 0. This time we're going to have 4 zeros after the decimal point before our 1, 6. And then we subtract. You can put a 0 here as a placeholder. It's actually not significant, but we need it to be able to subtract the 6. So that becomes 4. We're subtracting now. We're left with 4 here. 4 minus 1 is 3, and then 2, and then 0, 0, 0, and a 0 point. So our answer is supposed to be in standard form. So the final answer in standard form we have, it's going to be 2.34 times 10 raised to power what? 1, 2, 3, 4. So it's going to be 2.34 times 10 raised to power minus 4. That's the final answer. So to calculate in standard form, it's very easy. If the powers of 10 are the same in the numbers, you simply carry out the operation, add or subtract as required. But if the powers of 10 are different, like we have in number 3, you have to first simplify the numbers or write them out in full, carry out the operation. The operation we carried out here was take away. Yes? Carry out the operation, and then rewrite the answer in standard form. Try out some more examples from Brilliant Maths Module 1. Here we want to multiply or divide in standard form. Example 1. Multiply the following and write your answer in standard form. 2.4 times 10 to the power 4 times 5 times 10 to the power 7. This is actually very easy because you will simply group them. We can use the laws of indices. So we have 2.4 times 5, 2.4 times 5 times 10 to the power 4 times 10 to the power 7. And from the laws of indices, we know that 10 to the power 4 times 10 to the power 7 will give us 10 to the power 11. We simply add the powers. 4 plus 7 is 11. And then 2.4 times 5. 5 times 4 is 20. Carry 2. 5 times 2 is 10 plus 2, and that is 12. So that is 12.0 times 10 to the power 11. Then we need to write this in standard form, and that becomes 1.2 times 10 to the power 12. Take time to look at it. Example 2. Divide the numbers and write your answer in standard form. Solution. We have 6.4 times 10 to the power 7 divided by 1.6 times 10 to the power 3. We're also going to use the laws of indices. So we have 6.4 times 10 to the power 7, and we're dividing that by 1.6 times 10 to the power 3. We can subtract the powers of 10 because we are dividing, so it becomes 10 to the power 7 minus 3, and then we divide 6.4 by 1.6. And 6.4 divided by 1.6 is the same as 64 divided by 16, because both of them have just one place of decimal. And 64 divided by 16 is 4. So the answer becomes 4 times 10 to the power 7 minus 3 gives us 10 to the power 4, because 7 minus 3 is 4. The final answer is 4 times 10 to the power 4. You see how easy it is. Maths is easy and fun. Subscribe to brilliantmaths.com. Get our videos, get our modules. The modules come with answers and videos to go with them for you. It's all for you. Subscribe and get them. And see yourself excel in math. I am Ngozi Orevogen. And always remember that maths is fun.